Hi guys, this week we're going to focus a lot on something called equivalent fractions. Equivalent is a tricky word. It's long, for one thing, but it does have a beginning that you're familiar with because you know the word equal, you know the word equation, and equator. So let's think about equal. Equal means the same. And equation is where we have two sides, much like a balance beam, and the two sides are balanced or they are equal. We've done a lot of that this year. And the equator is a line that equally divides the earth from the top and the bottom. So the line is in the middle and the other parts are equal. So equivalent fractions have something to do with being equal, but they're not exactly the same and they're pretty tricky, and a lot of people spend a lot of time learning them. So we'll spend several days. When you think about the candy bar math that we did before, or if you think about pouring water into the measuring cups, we've been working with equivalent fractions all along. An equivalent fraction picture, which Carissa did a really nice job with solving some problems with circles the other day. If you have a picture of a half, and you have a picture of 2/4, and you're trying to say, are they the same or not? And if you make your pictures equal to begin with, then you could see that they would be equal or equivalent. So we're going to do that work on a number line today instead of with pictures or with models. So because we spent a lot of time with number lines last week, you're pretty familiar with these. So here's a number line, two number lines, and one is cut into halves and the other is cut into fourths. So let's take a look at this. 0, 1/4, 2/4, 3/4, and 1. So it says, is 1/4 equivalent to 1/2? So my first job would be to graph 1/4 on this line. And then I look at the other line and it's divided into halves. So I will graph 1/2 because I'm comparing 1/4 to 1/2. Are they equal? Well, how would I know? Well, they would be equal if they showed up in the same spot on the line. Do they match each other on the line? Do they come out in the same place on the line? They do not. So therefore, that we would say they are not equal. They are not equivalent. So the answer is 1/4 equivalent to 1/2. The answer would be no. Here's another example. This line is also cut in half, but the bottom line, notice is cut in eighths. So the question is 1/2 equivalent to 4/8? So first we would graph 1/2. And then we would graph 4/8. 1, 2, 3, 4/8. So are they equivalent? Are they equal? Do you notice that they're lined up in the same place? So they are equal, they are equivalent. So we would say that 1/2 is equal to 4/8. Now, we know that the pieces will be smaller if it's in eighths. Think of the candy bar, the pieces will be very tiny. However, if you have 4 of them, that would be the same as having 1 of the halves. It would be equal. You'd have a lot of little pieces here. You'd have 4 little pieces and 1 big piece, but because you had 4 pieces, that would make up the same amount as a half. So they are equivalent, and the answer would be yes. So you'll get to do some IXL practice. There'll be 2 number lines, and there will be 2 fractions that you would either graph or they're already graphed. And then you would check and say, are they in the same place on the number line? Do they match up? And if they do, then they are indeed equivalent, and you would say yes. If they don't match up, then you would say no. And remember that if you're stuck, that IXL has places to give you support. If you get it wrong, it will offer you an option to see from an example. And if you're stuck and you don't know how to answer the question, then you can go to the top where it can give you some hints with an example. Or you can write to me, and I would be happy to talk to you about it. Okay, good luck with equivalent fractions.